The next question is prove that sigma r is equal to 0 to n 3 raised to r into n cr is equal to 4 raised to n. So I am going to take the LHS. LHS is sigma r is equal to 0 to n 3 raised to r into n cr. Sigma stands for summation. Why r equal to 0 to n given us? Here instead of r we can give the value 0. The next value which I have to give is the next integer nearer to 0, which is 1. So I can give the value of r as first as 0, then as 1, then as 2, then 3, 4, 5, 6, etc. up to n. So it's a summation. So first term, how we are getting the first term is by putting the value of r as 0. So first term will be 3 raised to 0 into nc0. Summation stands for plus. So second term is separated by plus. Again, the next value which r takes is 1. So what we get? 3 raised to 1 into nc1. Plus the next value which r takes is 2. So 3 square into nc2. Plus etc. which is the last value, etc. Means there are many terms. We are now not going to write all the terms. Again, we will be writing the last term. The last value which r will take is n. So what will be the term? Plus 3 raised to, instead of r we have to replace by n. So 3 raised to n into ncn. Just simplify the term. 3 raised to 0 into nc0 is 1 plus 3 raised to 1 is 3 into nc1. I am not simplifying, let it be there. Plus 3 square into nc2 plus etc. plus 3 raised to n into ncn. What is ncn? ncn is 1. Okay. So what we get is 3 raised to 0 is 1. 1 into 1 is 1 plus. Here I am rearranging the term and I can write as 3 nc1 into 3. Here instead of 1 I can write the value 1 raised to n. 1 raised to any number gives you the value 1, isn't it? So I am just rewriting it as 1 raised to n. And here we have a 3, but I am writing a number 1 raised to n minus 1 by making 1 less than n. 1 raised to any number gives you the value. To identify the summation as an expression, I am doing this. There is no change in the value. nc1 into 3 is the term here. nc1 into 3 is the same as nc1 into 3 into 1. Instead of that 1, I wrote as 1 raised to n minus 1 as any power of 1 gives you the value 1. Plus here can you say the value, then nc2 remains the same. The power of 1 we have to reduce again. N minus 1 gives you n minus 2. And power of 3 is square, 3 square. Plus if I want to write the next term, how will I write? nc3 into 1 raised to, reduce the power again by 1, so n minus 3 into, increase the power of 3, 3 square plus etc. plus 3 raised to n. Now this looks like the form a raised to n plus nc1 a raised to n minus 1b plus nc2 a raised to n minus 2 b square plus etc. plus b raised to n, isn't it? This expression is of the form. This looks like the form a raised to n plus nc1 into a raised to n minus 1 b plus nc2 into a raised to n minus 2 into b square plus etc. b raised to n. And we know that this is the expansion of our binomial theorem, and we can write as it as a plus b whole raised to n. Okay, so here what I can write, the left side I took was sigma r is equal to 0 to n 3 raised to r into ncr. And here these terms look like this expression where instead of a raised to n, the value here is 1 raised to n. And instead of b raised to n, the value here is 3 raised to n. So a will be 1 and b will be 3. So the expression is a plus b raised to n. So a here in the summation is 1 and b is 3. So a plus b will be 1 plus 3 raised to n, which gives you 1 plus 3 is 4, 4 raised to n, which is our RHS. Just look, our question was to prove that the summation equal to 4 raised to n, and we got summation is equal to 1 plus 3 raised to n, 1 plus 3 is 4, 4 raised to n, which is our RHS.